right, so this is day 2. We are going to talk about applications of linear equations, and we're just going to do some word problems, and then I'm going to have a separate little video on using the calculator to come up with the regression equations given a set of data. So the first part today is this question. I hope you can see the question, or otherwise it should be on the notes. In 2010, a school population was 2,004 students. This is students, okay? It gets a little confusing because that's not a year. By 2020, the population had grown to this many students. Okay, assume the population is changing linearly. What is the average population growth per year? So we need students, the change in students over the change in years. So if we write students are going to be the y value, because this is change in y over change in x. So we have the year 2010 and the students 2004. And then we have the year 2020 and the students 2624. But down here it says eventually we're going to use t as years after 2000. Okay, I gotta stop the video. Okay, hope I get rid of the annoying noise. That was my dog chewing on his bone. So if we're doing years since 2000, we're going to subtract 2000 here and just call this term 10. And we're going to subtract 2000 here and just call this term 20. So again, the average rate of change would be 26. I can't write. Subtract 2004 students over 20 minus 10. So this is a difference of 620 students over the course of 10 years. What you divide out is 62 students per year that the population was growing. All right, can you determine the population would have been in 2000 if this pattern were true? We could do this several different ways. This was a change of 10 years, and it grew 620 students. If we wanted to go back 10 years, we could just do the population minus 10 years, which would be 620 students. It grew in 10 years. So we could do this, which gives us 1384. Or we could have gone directly to the equation, and we could have put in one of these ordered pairs and this, which we just found to be the slope. So we could have said y minus, let's see, we'll use the 2004 equals the slope of 62 times x minus 10. And again, that is using this point up here and our slope right here. So if we simplify that down a little, oh, I can't write. We'd get y equals 62x plus 1384 if I could write neatly. Still not very neatly. All right, but I'm going to rewrite it up here anyway because I'm going to put in the variables they asked. P equals 62 times the years, starting with 1384 in year 2000, which is the same thing we got doing it a little bit strangely using just some logic. Okay, use your equation. This is the whole reason you do this, is to be able to make a prediction. So if we're going to predict the population in the year 2025, First of all, we're going to take off our 2000 and say we need to use 25 years later, and that would be t. And we're just going to put that in here. So 62 times 25 years of growth from an initial 1384. I got 2,934 students would be present in 2025. Okay? That's basically the idea of the whole lesson today, with a couple little weird exceptions. This example is a little bit different because, let me see if I can move this. How's that? It says the Federal Helium Reserve reserves were at 16 billion cubic feet. We're just going to use 16 and label it billion cubic feet in 2015, and has been being depleted. So we need a negative slope here by, and this is 1.4 billion cubic feet each year, so that's already a slope. So write a linear equation. It's pretty darn easy. The reserves, let's see, it says years since 2015, so we can just use it started at 16, and it is going down 1.4 every, and it says to use t for years. I would have probably written it started at 16 and it's going down 1.4 every year. These are equivalent. Either one is fine. All right, what will it be in 2021? So this is 6 years later. So we're going to put a 6 in here in either one of them. And the reserves are 7.6, and that was billions of cubic feet, so we should label that. All right, C says if the rate of depletion doesn't change, when will the Federal Reserve be depleted? So do we want to put in 0 for what? Well, we want the 0 to go in for the reserves. So we would have 0 equals 16 minus 1.4t. If we subtract 16 from both sides and divide, 16 divided by 1.4 is about 11.4 years after we started, though. So we started counting in 2015. So if we add 2015, we have 26.4. So we would run out of helium, according to our prediction, will be depleted sometime during 2026, or you could say by 2027 we'd be out of helium. All right, so that was a pretty easy one. They gave us all we needed. All right, this is the kind that might be on a quiz. It says a gaming company charges a flat fee for monthly access and then a certain amount per minute that a customer is online playing the game. If a customer plays for 410 minutes, the bill was $71.50. The customer plays for 720 minutes, the bill was $118. Find a linear equation for the cost of the gaming plan as a function of X, the number of minutes played. All right, so they want us to use X as minutes and Y as money. So all we need to do is put in the two ordered pairs that we have. 410 minutes costs $71.50 and 720 minutes cost $118. Then to find a linear equation, just like we were doing yesterday, we're going to find the slope. So 118 minus 71.50 over 720 minus 410 comes out to be If I could type, 4650 over, I should be able to do that one in my head, right? 310. And if I divide that out, oh, I got an error. It comes out 0.15. So this is the slope, or 15 cents per minute played. Now it's 0.15 of a dollar or 15 cents. If we're going to leave the decimal in, we have to call it dollars, just so we're clear on that. All right, we have not finished finding the equation though. We need to put one of these points in or find the y-intercept. I'm going to stick with point slope because you really need to learn this. I think I'll use this one because it doesn't have a decimal, even though it has bigger numbers. Y minus 118 equals 0.15 times x minus 720. And I probably should have written this up here. We are using point slope, in case you thought I was doing magic there. Okay, now it says we want the equation in terms of cost, which is y. So let's do a little distributing here. Y minus 118 equals 0.15 x minus 108 plus 118 Now, somebody probably figured that out, because if you went back and said it's $15 a minute, back up here for 410 minutes would be 410 times 0.15, and you get 61.50. So look at the difference between this and 61.50 is $10. So the flat fee had to be 10. That's making sense. It's working with what we got here. So this is really our answer to A, except it should be, maybe we should write the cost equals 0.15x plus 10. All right, B says interpret the slope and intercept. Well, we just kind of went through that. The slope is 15 cents per minute, or you could write it 15 cents per minute, but then you have to leave off the decimal. You can't have dollar sign. You can't have a cent sign and a decimal, or else 0.15 of a cent. All right, and the intercept is our flat fee that they charge every month of $10. I didn't have a lot of room, so I didn't explain that very well. I probably should have written a sentence. All right, last part, use your prediction if somebody played 1,800 minutes. All right, so we would just take 0.15 times 1,800 minutes plus $10, and their bill would be $280. Okay, I hope that's a really fun video game if 1 month costs $280. And I hope you have a job. All right. Number 4, this is a different kind of question, but very real world. It says, when hired at a new job selling internet service, you're given 2 options. You could take a base salary of $25,000 a year and get a really good commission of 15% on all your sales. Or you could start at $33,000 a year and get a commission of only 5%. So it says, how much money, dollars worth of internet would you need to sell for option A to produce a larger income? So in your first year, you want option A to be greater than option B based on what you're selling. Well, they are adding onto your paycheck 15% of your sales. If we say X is the dollars of service sold. Okay. How do we say 15% of X? Well, I hope you remember 15% becomes 0.15. We got to do that here, 0.15X. And then 5%, when we move it back twice, becomes 0.05. Right, then we just need to solve. It's not that important that this is an inequality, just so we know how much we would need to sell. I'm going to solve it as an inequality. It won't matter. Remember, the thing with inequalities is sometimes you have to flip if you multiply or divide by a negative, but I don't think that's going to happen here. We get X is greater than 80. Let's double check. I think it's 80,000. Okay. 8,000 divided by 0.01 is 800,000. See, I almost messed that up. All right. So you would need to sell more than $800,000 worth of internet. Oh, that's because I did this wrong. All right, I don't know. Sorry, guys. I'm not recording the video, but right here, this should have been 0.1. I don't know why I suddenly moved it too far. I thought 800,000 sounded too big. Okay. So I remembered making a key for this. Sorry if you're figuring out where that came from. Just know that I fixed it. So how much internet would you need to sell for option A? Need to sell over, oh, we can't write. $80,000 in internet service. Okay, in order to make it worthwhile to take that first one. If you knew you could sell $200,000 in internet service, then you'd be all over that first option. Otherwise, it'd be better to take the second option. All right, one more question on this video. This says the median homes in Mississippi and Hawaii adjusted for inflation are shown below. If we assume that the house values are changing linearly, we had 1970. The Mississippi home was worth this, and in 2010 it was worth this. Now we have to decide if we're going to use like years since 1900 or years since 1950 or years since 1970. You know what? That would be really sweet if we use years since 1970. I'm going to show you a trick. If we use years since 1970 for X, then this ordered pair for Mississippi becomes 0. Anybody recognize that? Over 0 and up this is your y-intercept. When we have to find a line in a minute, that's your y-intercept. Now we have to be a little bit careful. 2010 minus 1970 is 40 years, so this would be term 40 is 81,400. All right, find the rate at which the homes are increasing. So we need the slope. So 81,400 minus 3,200. 51,200 divided by 40 years. This one is growing by $1,280 per year. Hawaii, on the other hand, 0 was 87,400, and 40 years later it was up to 304,400. I'm going to assume you know how to calculate the slope by now, so I'm going to write 304,400 minus 87,400 is 217,000 divided by 40 years. This, in Hawaii, the property was growing over $5,000 per year. Now it says if these trends continue, find the median home value in 2020. So we need an equation, and then we need to make a prediction. And we will put in X equals, let's see, years since 1970 would be 50 years. Well, we got a little cheater thing going here. We could use point slope and put in a point and a slope, but we have already the y-intercept because we called this year 0. So in Mississippi, it's growing by 1280 a year, and it started at 3,000 or 30,200 because we called that year 0. And in Hawaii, it's growing 5425 a year, and it started year 0 at 87,400. So if we want to put in 50 to figure out the value at the end of each of these, or for each of these homes in 2020, typing quickly, making sure I don't mess anything up, I get the Mississippi home is up to 94,200, but the Hawaii home from 87,400 is all the way up to $358,650. Okay, so Hawaii started out more expensive for homes, and it has grown even faster, so that the difference between the two has increased. All right, that's writing equations from word problems. Pretty easy. Part 2 of the video will be linear regression, so you're going to need a calculator with graphing functions for that.